Hello, and welcome to my YouTube channel called Statistics from A to Z, Confusing Concepts Clarified. These videos are based on content from my book of the same name, which is published by Wiley. For more information on the book and these videos, please visit statisticsfromatoz.com. This video is part 2 of a series of 3 videos on the overall subject of probability distributions. Part 1 described what they are. This video will explain how they are used, and Part 3 will tell you which distribution can be used for which statistical purpose. In addition to these 3, the book also has individual articles on each of the 8 families of distributions shown here. My plan is to eventually produce videos for each of them. See statisticsfromatoz.com/videos for the latest status of this work. As usual in the book and in these videos, we'll go quickly through a list of keys to understanding to give you the overall picture, and then we'll go into detailed explanations of each of the keys. For this video, there are 5 KTUs. The first key to understanding is a discrete distribution, like the binomial, hypergeometric, or Poisson, can provide probabilities for individual values of x or cumulative probabilities of a range of values. The second KTU says that a continuous distribution associated with a test statistic, like z, t, f, or chi-square, can take a value for the cumulative probability alpha and give us a critical value of the test statistic. Key to understanding number 3 says, or a continuous distribution can take a calculated value of the test statistic and give us a cumulative probability, the p-value. The fourth key states, then we can compare p to alpha, or equivalently, we can compare the critical value to the value of the test statistic in order to determine the outcome of a hypothesis test. Alternately, we can use the critical value in the confidence interval method. And the final key to understanding says, which distribution to use is dependent on the type of data and the type of test or analysis. That is the subject of the Part 3 article and video. In here on one page are all 5 keys to understanding the concept of what probability distributions can do and how they are used. You may wish to pause the video at this point to read them all together. Let's now begin our detailed explanation of each key to understanding. In a discrete distribution, the horizontal axis shows a set of discrete separated values. These are usually counts, which are non-negative integers starting at 0. The probability of each integer is depicted by the height of a rectangular bar. As a result, the graph of the distribution is not a continuous curve. Instead, it is depicted as a series of adjacent bars. It has more of a stair-step pattern to it. The height of each bar shows the probability of an individual count. If we want to know the probability of a range of counts, we just add up the individual probabilities within that range. For example, the probability that x equals either 0 or 1 is just the sum of those 2 probabilities. In this example, the probability that x equals 0 is 0.050, and the probability that x equals 1 is 0.149. So the probability that x is either 0 or 1 is 0.050 plus 0.149, which equals 0.199. But what if we want to know the probability that x is greater than 5? We could try to add up the probabilities of x equals 6, 7, 8, and so on, but there would be an infinite number of them, and their individual probabilities would be very small. Well, We know that the probability of all possible values of x is 100%. That is 1.0. So we just add up the individual probabilities of those numbers which are not in the range and subtract from 1. As shown here, the probability of x being 0 through 5 is 0.916. So the probability of x being greater than 5 is 1 minus 0.916, or 0.084. As noted in the Part 1 video, we can't do this for continuous distributions because they have an infinite number of x values, but we can use calculus and integrals to calculate the area under the curve. Statistical tables or software will do this for us. Key to understanding number 2. A continuous distribution associated with a test statistic, like z, t, f, or chi-square, can take a value for the cumulative probability alpha and give us a critical value of the test statistic. In hypothesis testing, one of the first steps is to select a value for alpha, the significance level. Alpha is a cumulative probability. If we plot alpha as a shaded area under one or both tails of the distribution of a test statistic, then software or tables can give us the point value of the boundary of that shaded area. In this example, the tester selects alpha equals 5%, and she is using the standard normal distribution. The test is right-tailed, so alpha is depicted as the shaded area under the right tail, extending to infinity. Tables or software can tell us that the boundary of the shaded area under the right tail is the point value z equals 1.645. This is the critical value. In the previous slide, we started with a cumulative probability and we calculated the point value which forms its boundary. Here we are doing the opposite. We start with a point value and we use it to form a boundary, and the boundary is for an area under the curve, which is a cumulative probability. In this example, we have collected a sample of measurements of height in centimeters as shown in the box. We use the formula for the test statistic z to calculate a value for z from the sample data. Z is calculated to be 1.2 in our example. Then we plot that point on the horizontal axis of the test statistic z. This becomes the boundary of an area under the curve. And the distribution tells us that if z equals 1.2 and the test is right-tailed, then the area under the curve to the right of 1.2 is 11.5%. This cumulative probability is known as p, the p-value. We just went very quickly through the concepts of alpha, p-value, critical value, and test statistic. These are very important statistical concepts, and each of them can be confusing to many people. That is why the book has 4 articles on the 4 individual concepts, and a 5th on how they work together. I have uploaded 5 videos corresponding to these 5 articles. They are in a playlist on my channel called Central Concepts in Inferential Statistics. The 5th video, I think, covers the most valuable topic in the book and in these videos. It explains how these 4 concepts interrelate and work together, and it summarizes these interrelationships onto a 1-page graphic. I would urge you to view it. I have seen nothing as helpful anywhere else. Key to understanding number 4. Then we can compare p to alpha, or equivalently, we can compare the critical value to the value of the test statistic. This will determine the outcome of a hypothesis test. Alternately, we can use the critical value in the confidence interval method. You might elect to pause the video and read the contents of this visual in detail. It summarizes a lot of information in one place. It is explained at length in the video P, the p-value, so I won't go through all that here. If you already had a fair amount of understanding of the concepts on the previous slide, that table may have been helpful in solidifying that understanding. But if not, you may benefit from more information on hypothesis testing. There is another playlist on my YouTube channel devoted to hypothesis testing and the concepts which it employs. Each of the videos in these playlists is also the subject of its own article in the book. The final key to understanding says, which distribution to use is dependent on the type of data and the type of test or analysis, and that is the subject of the Part 3 article. We said earlier that certain distributions would work with discrete or count data, others work with continuous data, and others work with both. You could use some distributions when working with the means, and others when working with standard deviations. Some distributions work with proportions. You would use a different one when working with time intervals. And all this will be explained in the Part 3 video. Okay, that concludes our overview of what probability distributions are used for and how they are used. If you liked this video, please remember to press the thumbs up like button on your screen below. I'll be making more videos of some or most of the 60+ concepts in the book if folks like you tell me that more videos are wanted. Please subscribe to this channel to be notified when new videos are uploaded. Also, the website statisticsfromatoz.com has a listing of available and planned videos. Now, videos like this one can be very helpful, but they're not very handy when you want to quickly look up something on the job while studying or during an open book exam. For that, nothing beats a book or an ebook. You can also learn more about those on the website. I'd recommend following my blog at statisticsfromatoz.com/blog. I've got some things there that hopefully you'll find interesting, like a Statistics Tip of the Week series, as well as posts showing that you are not alone if you're confused by statistics. I'll also be posting on the Facebook page Statistics from A to Z and on Twitter as @StatsA to Z.